Okay, in this video, I'm just going to review for the final exam for college algebra. There will be two parts to this video. The first part is just going to be approximately 1 hour in length, depending upon how much I'm able to cover what's on this review sheet, and whatever I don't finish will be on the next video. I do need to remind you that you will be allowed a one sheet of notes with writing on both sides, front and back. What's on the study guide is similar to what you will expect to see on the final exam, and there will be 30 questions in length. All right, so we're going to start with problem number 1, where you're going to solve the linear equation x minus 3 divided by 3 plus x plus 5 divided by 2 is equal to 19 over 6. Okay, so let me go ahead and write down the problem. Here we got x minus 3 divided by 3 plus x minus 5, x plus 5, divided by 2, and that's equal to 19 over 6. Now here we got an equation that has fractions in them, so what we need to do there is find a least common denominator, or in short, the LCD of our denominators that are given, and that's 3, 2, and 6. So the least common denominator for 3, 2, and 6, that's the smallest number that's divisible by 3, 2, and 6, will have to be 6. So that means I'm going to multiply every single term in this equation by 6. So that means that this 6 will be multiplied by x minus 3 over 3 plus this 6 will be multiplied by x plus 5 divided by 2, and that's equal to 6 times 19 over 6. And then we go ahead and simplify this equation. So if I divide this 3 into this 6, that's going to go 2 times. So here I'm going to have 2 times the quantity x minus 3 plus, and if I divide this 2 into the 6, that's going to go 3 times. That would be 3 times the quantity x plus 5. And that's equal to, and then the 6's divide out here on the right side. I'll be left with 19. So now I have an equation that I can easily remove the parentheses and combine some like terms here. So if I distribute the 2 over the x minus 3, I would end up with 2x minus 6, and then plus, distribute the 3 over the x plus 5, that would be 3x plus 15, that's equal to 19. Now you want to make sure you distribute the 2 over all the terms in the parentheses and the 3 over all the terms in the parentheses, because that's 2 times x, that's 2x. 2 times the minus 3 will be minus 6, and here 3 times x would be 3x, and then 3 times 5 would be plus 15. Next step would be to combine like terms here. Add 2x and 3x together, I would get 5x. Minus 6 and a plus 15 would be a plus 9. And 5x plus 9 will equal 19. And then to get x by itself, I have to start by subtracting 9 on both sides. So that means I have 5x is equal to 10. Then divide both sides by 5. That means x is equal to 2. Now, if you have the time, you can check this proposed solution here, but here x equals 2 is the solution to that linear equation. So that's problem number 1. Problem number 2 deals with solving this equation x squared minus 2x plus 17 equal to 0 using the quadratic formula. So here we got x squared minus 2x plus 17 is equal to 0. Now we're going to use the quadratic formula, but you want to make sure that this equation is written in the general form, meaning that there's a 0 on one side of this equation and all the terms on the left-hand side here. So from that, we can identify the a, the b, and the c. The a is the coefficient of your x squared term. In this case, it's going to be 1. The b is the coefficient of the linear term, or x, which is -2. C is the constant term, 17. And the quadratic formula is this: x equal -b plus or minus the square root of b squared minus 4ac, all that's divided by 2a. Negative x equal -b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's your quadratic formula. Now we're going to substitute the a and the b and the c in that quadratic formula and simplify. So here I'm going to bring this negative sign down. The b is -2, so it'll be negative of -2 plus or minus the square root of. B is -2 again. So it's -2, and that's squared, minus 4 times a, which is 1, times c, which is 17. And the whole thing is divided by 2a. Now we simplify all of this. Negative of -2 would be 2, plus or minus the square root of. Square the -2, that's like -2 times -2, which is 4. Minus 4 times 1 will be 4 times 17 will be 68. All that's divided by, and I forgot to replace this a with a 1. So that denominator should be 2 times 1. And 2 times 1 will be 2. So here we got x equals 2. Bring down the 2 plus or minus the square root of. -4 minus 68 would be -64. And this whole thing would be divided by 2. Now, if you take the square root of a -64, well, the square root of 64 is 8, because 8 times 8 gives me 64. But the negative sign means that there's -1. And the square root of -1, if you recall, would be I. So I have 2 plus or minus 8i divided by 2. And what I'm going to do here is go ahead and break this up as 2 divided by 2 plus or minus 8i divided by 2. Now 2 divided by 2 will be 1, plus or minus 8i divided by 2 would be 4i. And you can leave your answer like this, as 1 plus or minus 4i. Or if you wish, you can write that as 1 plus 4i and 1 minus 4i. So that's problem number 2, using the quadratic formula. Problem number 3 is to solve the equation by factoring. Here we got x cubed minus 14x squared plus 48x equal to 0. Now we're going to solve this by factoring as indicated in the directions here. Well, let's find a common factor that's in x cubed, 14x squared, and 48x. And in this case, let's start off with the x, because x is common in all three of those terms, and we take the one with the smallest exponent, so it'll be x to the 1 for just x. So we factor out the x. And then to get what's on the inside, we divide the x into each one of these terms here. So x cubed divided by x will be x squared, minus 14x squared divided by x will be 14x, plus 48x divided by x will be 48. And that's going to be equal to 0. So now I'm going to bring this x down. Now that trinomial x squared minus 14x plus 48 equal to 0. I can factor that out into two binomials here. Let's see, x squared breaks up as x and x. The middle term has a minus sign, the last term has a plus sign, so that means they both have to be minus, and I need factors of 48 that will give me 14x as a middle term. It will have to be 6 and 8, because negative 6x and a negative 8x will give me minus 14x. So factored completely, I get x times x minus 6 times x minus 8 equal to 0. And then I set each factor equal to 0. So this means x will be equal to 0, or I can say that x minus 6 is equal to 0, or x minus 8 is equal to 0. Well, x equals 0 is already solved for x. Now for the x minus 6 equal to 0, if I add 6, that means x is equal to 6. And then for x minus 8 equal to 0, if I add 8, that means x is equal to 8. So these are the zeros of this polynomial function, or polynomial equation, I should say. 0, 6, and 8. Okay. So that's problem number 3. Now in problem 4 of your study guide, we have this radical equation. The square root of 5x plus 14 is equal to x. This is the one that you're going to have to check your proposed solution, because you may have an extraneous solution when you solve this equation for the variable. So here we got the square root of 5x plus 14 equals x. Square root of 5x plus 14 is equal to x. Now in this case, we already got the radical by itself, that square root. We need to get rid of that. So the opposite of taking the square root of something would be to square both sides. So what I'm going to do here is take the square on both sides of this equation. Now when I square both sides, on the left side, the square root and the square are inverses. So that's gone. You're left with what's underneath that radical, which will be 5x plus 14. And that's equal to x, and that's squared. So now I have a quadratic equation. So what I need to do there is get a 0 on one side of this equation, so I can get it in what we call the general form. So I need to move the 5x and the plus 14 over to the other side by subtracting 5x on both sides, and also subtracting 14 on both sides. So I have a 0 on the left side. The right side, I'm going to have x squared minus 5x minus 14. Now, with that x squared minus 5x minus 14, I'm going to factor that out into two binomials here. So what that means here is this. The x squared breaks up as x and x. Factors of a negative 14 that will give me negative 5x as a middle term will have to be minus 7 and a plus 2. The 7 has to be a minus sign because the middle term, the 7 is the larger of the two factors as it takes the sign of that middle term, which is minus. So it's x minus 7. And then the 2 has to be plus. So you have x minus 7 times x plus 2 is equal to 0. And then we set each binomial factor equal to 0 and solve for x. So this means I have x minus 7 is equal to 0, or x plus 2 equal to 0. And then we solve each equation for x. So for the x minus 7 is equal to 0. Well, if I add 7, I'm going to get x equals 7. Or for the x plus 2 equal to 0, I'll get x is equal to negative 2. So these are my two proposed solutions. But for each proposed solution, I need to check to see which one will satisfy this equation. So if I start with the x equals 7 and use the original equation and substitute each x with the 7, here's what I'll have. The square root of 5 times x, which is 7, plus 14. And I want that to be equal to x, which is 7. Now, if I do 5 times 7, that's going to give me 35. So I have the square root of 35 plus 14. That's equal to 7. Add 35 and 14 together, I have 49. So the square root of 49 must be equal to 7. And if I take the square root of 49, it does equal to 7. So 7 equals 7 means that this does check. So that means that x equals 7 will be my solution for this radical equation. And there should be only one solution here. So that means that this x equals 2, x equals negative 2, I can eliminate that altogether. And if you want to, you can check for x equals negative 2 here and replace the x or negative 2 in the original equation. So it'll be 5 times x, which is negative 2, plus 14. We want that to be equal to negative 2. But pretty much you can see that this is not going to make sense here. 5 times negative 2 will be negative 10 plus 14 equals to negative 2. Negative 10 plus 14 will be 4. And if you take the square root of 4, it's going to be equal to 2, which does not equal to negative 2. So that's a false statement. And by the way, the square root of something can't be negative. Okay, so that means x equals 7 is the actual solution to that radical equation. And with this one, it is expected that you do the check on these on the proposed solutions here. Okay. All right, now on to problem number 5. Here we got the absolute value equation here. Absolute value of 3 times the absolute value of 2x minus 5 plus 4 is equal to 25. So I'll go ahead and write that down. I'm sorry, 2x minus 5 plus 4 equals 25. And then we want to get the absolute value of 2x minus 5 by itself first. So that means I need to move some terms that are on the outside of the absolute value symbol over to the other side. Starting with that plus 4. I need to subtract 4 on both sides. So I'll have 3 times the absolute value of 2x minus 5 is equal to 21. Now I still need to get the absolute value of 2x minus 5 by itself. I'm multiplying it by 3, so the opposite of that would be to divide both sides by 3. So here we got the absolute value of 2x minus 5 is equal to 7. So now to solve this, I need to write this as 2 separate equations. An absolute value equation, you must write it as 2 separate equations. So the absolute value of 2x minus 5 equals 7 means that 2x minus 5 will equal to 7, or 2x minus 5 is equal to negative 7. And for each equation, I'll solve for x. So for the 2x minus 5 is equal to 7, if I add 5, I have 2x is equal to 12. And then to solve for x, we'll divide by 2. That means x is equal to 6. Or for the 2x minus 5 is equal to negative 7, Now I'm still going to add 5 to both sides, but this time 2x will be equal to, now negative 7 plus 5 will be negative 2. So 2x equals negative 2. Divide both sides by 2. X is equal to negative 1. And these are my two solutions for this absolute value equation, x equals 6 or x equal negative 1. Okay, so that's problem number 5. Number 6. Now here I have a regular inequality that I'm going to solve. So here I got 7 times the quantity x minus 8, then plus 3 is less than 6 times the quantity x minus 5 plus 3x. Okay. And by the way, feel free to pause the video if necessary, so that way if you want to copy some things down here. So feel free to do that. All right, the left side I need to distribute the 7 over the x minus 8. So here I have 7 times 8, x will be 7x, minus 7 times 8, that'll be 56. Bring down the plus 3 is less than, distribute the 6 over the x minus 5. So 6 times x will be 6x, minus 6 times 5 will be 30, plus 3x. All right, so now combine like terms on each side. Let's see, if I bring the 7x down, negative 56 plus 3 will be a negative 53. So 7x minus 53 will be less than. On the right side, combining like terms, 6x and 3x is 9x. And then minus 30. Okay. Now, when you're solving an inequality, it would be best to move the variable terms over to the left-hand side. So I'm going to move the 9x over to where the 7x is. And I'm going to do that by subtracting 9x on both sides. And when I do that, 7x minus 9x will be negative 2x. Minus 53 is less than, and don't forget to bring this negative sign in front of the 30. It would be negative 30. And then to get that negative 2x by itself, I'm subtracting 53, so I need to add 53 to both sides. So now negative 2x is less than, negative 30 plus 53 will be 23. And then to get x by itself, I'm going to divide both sides of this inequality by negative 2. But when I do that, this inequality symbol, since I'm dividing both sides by negative, it flips from less than to greater than. And since I'm going to get a mixed number here, I'm just going to leave this as negative 23 over 2. I'll just leave that as an improper fraction. Not saying that you'll have an improper fraction as a final answer on your final exam, but you can leave it as an improper fraction here. So here, x is greater than negative 23 halves. Okay. And in that case, you're just solving the inequality, not graphing the solution set. All right, so that's problem number 6. Number 7 is an absolute value inequality. So you want to pay close attention to your inequality symbol and how to write an absolute value inequality. Here you got the absolute value of 2x plus 13 is greater than 7. Absolute value of 2x plus 13 is greater than 7. Notice the absolute value symbol is by itself, and we got the greater than symbol. Anytime you have greater than or equal to, you're going to write this as two separate inequalities. However, if you have less than or less than or equal to, then you'll have to write this as a compound inequality. Since we got greater than in problem number 7, we're going to write this as two separate inequalities. The first one would be 2x plus 13 is greater than 7, and then or 2x plus 13. This greater than symbol will change to less than. Positive 7 changes to negative 7. Okay, so you might have to refer back to section 1.7 on how we write absolute value inequalities. Each inequality, we're going to get x by itself. So the 2x plus 13 is greater than 7. We're going to subtract 13 on both sides. So that means I have 2x is greater than 7 minus 13, that's negative 6. Divide both sides by 2. X is greater than negative 3. And then for the 2x plus 13 is less than negative 7. To get the 2x by itself, you're going to subtract 13 on both sides. So 2x is less than negative 7 minus 13 is negative 20. Divide both sides by 2. X is less than negative 10. And I will leave that answer as is. So for this, it'll be x is greater than negative 3 or x is less than negative 10. Okay. Now problem number 8. You're going to select the graph of a relation which is not a function, is not one-to-one, and is one-to-one. So I'm saying graph A, then graph B, and then graph C. Let's start off with which one is not a function. What that means here is this: for it not to be a function, you cannot have an x value going to two different y values here. And by looking at this, you can see that b would not represent a function because you got 1 paired with 5 and 11. So we can say here that graph B, where I have b here is not a function. Okay. And then, which one is not one-to-one? For a relation to not be one-to-one, you can't have a y value going to two different x values. C would not be one-to-one because you got 3, which is your y value, with two x values, negative 4 and negative 1. So graph C, or mapping C, is not one-to-one. And for A, what's left? Is one-to-one or have to be A? That's all that's left. So graph A is 1-to-1. And what that means here is that you only got one y value to one x. And for it to be a function, only one x to one y. Excuse me. All right, number 9 is to evaluate the function f of x is equal to 3x plus 9, and that's only if x is less than 1, or x squared plus 1, and that's only if x is greater than or equal to 1. And this is going to be for x is equal to 5. So here you have a piecewise function. And you have to pick which one of those functions you're going to use based upon that x value. Okay. That's problem number 9, not 8. So here we got the 3x plus 9, and we use that if x is less than 1, and the other one is the x squared plus 1 if x is greater than or equal to 1. And this is only for x is equal to 5. So in this case here, we're just going to evaluate f of 5. And this x value tells us which one of these expressions we're going to have to use here. Here 5 is greater than or equal to 1, so we have to use only the x squared plus 1. So that means I'm going to substitute the x here in that x squared plus 1 with 5. So it'll be 5, and that's going to be squared, plus 1. And if I square the 5, that's going to be 25. 25 plus 1 is 26. So the value of this piecewise function when x is equal to 5 will be 26. Okay. Right. Problem number 10. Now here we have a function where we're going to find its domain. We got f of x is equal to 18x squared plus 123x minus 203 divided by x squared plus 5x minus 24. Now the type of function that we have in number 10, as I write this down, is a rational function. Because we have a numerator, and then we got a denominator where there's an x there in that denominator. That means we need to find out what values of x that would give us a 0 in this denominator, since it's a rational function. So in this case here, I'm going to take that x squared plus 5x minus 24. And set that equal to 0 because I want to find out what values of x that would give me 0 in this denominator. Well, I got a quadratic equation, so I need to factor the left-hand side into two binomials. So x squared breaks up as x and x. And then I need factors of a negative 24 that gives me 5x as a middle term. Well, let's use 8 and 3. And of course, the larger of the two factors takes the sign of that middle term. The middle term has a plus, so that 8 will have to be plus. The 3 has to be minus, so that 8x minus 3x will give me 5x as the middle term. So I got 8x plus 8 times x minus 3 equal to 0. And then we set each binomial factor equal to 0. So that means I'm going to have x plus 8 is equal to 0, or x minus 3 equal to 0. And then for each equation, we're going to solve for x over the x plus 8 equal to 0. That means x is equal to negative 8. Or for the x minus 3 is equal to 0. That means x is equal to 3. All right, now let's say I want that answer to be, my domain to be in interval notation. Now, if this helps, you can draw a number line like this. Let's see, negative 8 will be over here somewhere. Positive 3 will be here. We know at x equal negative 8, we're going to have a 0 in the denominator, so we can put parentheses there. And 3, we know is going to have a 0 in the denominator. Any x value less than negative 8 would work, or satisfy this rational function. Anything between negative 8 and 3 would satisfy that rational function, and any x value greater than 3 would satisfy that rational function. So my domain, if it was written in interval notation, would be this. From left to right, this goes indefinitely to the left, so it would be negative 8, negative infinity, up to negative 8. or, and I'm using the union symbol for or, -8 to 3, or from 3 to infinity. This represents the domain for this rational function in problem number 10. Okay. All right, now problem number 11. Here we got two functions, f of x is equal to 3x minus 1, and g of x is equal to negative 7x plus 2. We're going to find f minus g of x. And g of x is equal to negative 7x plus 2. Here we're finding f minus g of x. F minus g of x. Now, what f minus g of x means is this. It's just simply subtracting the two functions, f of x minus g of x. And my f of x is that 3x minus 1, minus g of x is negative 7x plus 2. Notice I'm putting the entire g of x function in parentheses because I'm subtracting the entire g of x function from f of x. So that's why you see the parentheses here. Now let's simplify a bit. Bring down the 3x minus 1. This minus sign makes a negative 7x plus 7x. The minus sign makes a plus 2 minus 2. Now when we combine like terms, 3x and 7x will give me 10x. And then minus 1 and a minus 2 will be minus 3. So I end up with 10x minus 3 as the difference of the two functions f and g, or f minus g of x. Okay. So that's problem number 11. Problem number 12 is this. For the functions f of x is equal to 2x plus 5 and g of x is equal to x squared minus 7, we're going to find the composition of f with g of x. That's what that notation stands for. All right, so let me write down my two functions. F of x is equal to 2x plus 5. And g of x is equal to x squared minus 7. And I want the composition of f with g of x, or sometimes they call it f circle g of x. Which actually means f of g of x. So now g of x is the inside function, whereas f of x is the outside function. Well, g of x is equal to the x squared minus 7, so I'm going to replace this g of x with what it's equal to. So I'm going to bring down f of, replace the g of x with x squared minus 7. Now, of course, my f of x function, as you see, is given to me as 2x plus 5. Now, this means when we take the composition of those two functions, so when I'm doing f of g of x, every single x in the f of x function, I'm going to replace it with what g of x is. So that means this x in the f of x notation will be replaced with what g of x is, and that's this x squared minus 7. And in the 2x plus 5, this x will be substituted with what g of x is, and that's x squared minus 7. Now I'm going to simplify just the right-hand side. Distribute the 2 over the x squared minus 7. I'll have 2 times x squared will be 2x squared minus 2 times 7, which is 14, and then plus 5. Okay, now if I combine like terms, bring this 2x squared down, minus 14 plus 5 will be a minus 9. So I end up with 2x squared minus 9, which means that the composition of f with g of x would be 2x squared minus 9. Okay. All right, so that's problem number 12. All right, number 13 is determining the functions f of x and g of x such that f of g of x, or the composition of f with g of x, will be 5 divided by the quantity x squared minus 3x plus 6 raised to the 6th power. So here we got f of g of x, that's equal to 5 divided by the quantity x squared minus 3x plus 6. That's going to be raised to the 6th power. And here I want to find out what f of x is, or what f of x was to begin with, and what g of x was to begin with. Now, in this case, the g of x is always the inside function in this case, which means if I take this x squared minus 3x plus 6, I'll treat that as the inside function, because that's going to be what g of x is. So that means g of x will be, in this case, the x squared minus 3x plus 6. But for f of x, it's going to be that 5 in the numerator divided by this g of x was put in place of x. So f of x had to start off with the x raised to the 6th power in the denominator. So f of x was 5 divided by x to the 6th. So these are my two functions, f of x and g of x, that gives me this to begin with. F of x was 5 over x to the 6th. G of x was x squared minus 3x plus 6. Okay. All right, problem number 14. Is f of x is equal to 2x minus 6, and we want to find the inverse of that function, or f inverse of x. So here we got f of x is equal to 2x minus 6, and we want to find f inverse of x. Well, to do that, we first have to write this in terms of y, so we need to substitute the f of x notation and put it in place of it y. So it'd be y equal to 2x minus 6. And then we interchange x and y. So that means the y becomes the x, and this x becomes y. So it'd be x equals 2y minus 6. That's step number 2, interchanging x and y. And then solve this equation for y. So to get y by itself, the first thing you need to do there is add 6 to both sides. So that means x plus 6 is equal to 2y. And then to get y by itself, I'll divide both sides by 2. That means y is equal to x plus 6. All of it is divided by 2. And then the fourth and the final step would be to replace the y with the f inverse of x notation. So this is f inverse of x equaling to x plus 6 divided by 2. And that's all there is to it. So f inverse of x would be x plus 6 all divided by 2. All right. Problem number 15. Now I'll write that over here. And this is on the next page of your study guide. Find the coordinates of the vertex of the parabola defined by the quadratic function f of x is equal to 2x squared minus 12x plus 3. Okay. There are two things I need to identify. I need to identify the a and the b. Well, the a is the coefficient of my x squared term, that's 2. The b is the coefficient of the x term, negative 12. So to find the x-coordinate of the vertex, I use x equal negative b over 2a. So I'm going to substitute the b with negative 12, bring this negative sign over. So it'll be negative of negative 12 divided by 2 times a, which is 2. Well, negative of negative 12 will be positive 12 over 2 times 2, which is 4. 12 divided by 4 is 3. So the x-coordinate of that vertex is going to be 3. Now to evaluate the y-coordinate of the vertex, I'll take the x equals 3, substitute for each x in the f of x function. So f of 3 will be this. 2 times x, which is 3, and that's squared, minus 12 times x, which is 3, plus 3. And then simplify. Using order of operations, if I square this 3, that's going to be 9. 9 times the 2 in front would be 18. Minus 12 times 3, that's 36, plus 3. And if you do 18 minus 36, that's going to be negative 18. Negative 18 plus this 3 will be negative 15. That represents the y-coordinate of that vertex. So the vertex here will be the ordered pair 3, negative 15. Okay. So that's problem number 15. And that's half the review sheet that I've covered. All right, number 16 is where you're going to be graphing a quadratic function on a coordinate plane. You'll have a coordinate grid on the final exam. So here you're going to sketch the graph of the parabola f of x equal x squared plus 4x minus 5, and you're going to follow those 4 steps. A, you're going to find the y-intercept. B, find the x-intercept. C, identify the vertex by using the formula for the coordinate x-coordinate of the vertex, and then use these points and a point symmetric to the y-intercept with respect to the axis of symmetry of the parabola to sketch the graph of the parabola. Okay, so now I'll write the equation down and start with part A is finding the y-intercept. Anytime you're finding the y-intercept, you always let x equal 0 and solve and simplify. So we're going to evaluate f of 0 by substituting every x in that function with 0, which should be quite easy in this case because this is going to be 0 squared plus 4 times 0 minus 5. 0 squared is 0. 4 times 0 is 0 minus 5 ends up being negative 5. So the ordered pair for the y-intercept would be 0, negative 5. And of course, you have to write it as an ordered pair because the y-intercept, you're letting x equals 0 and the y value Whatever you get for that will be your y-coordinate. 0, -5 is your y-intercept. Part B is finding the x-intercept. I say x-intercepts because there might be more than one. When you find the x-intercepts, you always let f of x, the function itself, be equal to 0. So if you let f of x equal to 0, f of x in this case will be x squared plus 4x minus 5. And that's equal to 0. Well, in this case, let's see if we can factor that trinomial into two binomials here. X squared breaks up as x and x. Only factors of 5 that I have will have to be 5 and 1. But the larger of the two factors takes the sign of the middle term. The 4x has a plus sign, so the 5 has to be plus, the 1 has to be minus, since that last term was a minus sign. So I get x plus 5 times x minus 1 equal to 0. And then we set each binomial factor equal to 0. So this means x plus 5 is equal to 0, or x minus 1 equal to 0. And then we solve for x for each of these equations here. So for the x plus 5 equal to 0, that means x is equal to -5. And then for the x minus 1 equal to 0, that means x is equal to -1. X equal 1. X minus 1 equals 0 means x equals 1. So I have two x-intercepts here. One would be -5, 0. The other one would be 1, 0. Those will be the points where the graph of this parabola crosses the x-axis. Okay. So that's part B. Part C, we have to find the vertex of this parabola. The vertex. So we have to use the formula for the x-coordinate of the vertex here. I need to identify what A is and what B is. A, of course, is the coefficient of your x squared term, which is the understood 1. The B is the coefficient of your x term, which is going to be 4 from this quadratic function. And then using x equal -b over 2a, substitute, bring this negative sign over, replace the b with 4, divided by 2 times a, which is 1. So again, -4 over 2 times 1, which is 2. -4 divided by 2 is -2. So I know my x-coordinate of this vertex is going to be -2. I need to know the y-coordinate of that vertex. So to do that, we just substitute the x in the original function with -2. So f of -2 would be this. That x squared, I have -2 and that's squared, plus 4 times x will be -2 minus 5. -2 squared, or -2 times -2, would be 4. 4 times the -2 will make that -8, and then minus 5. Well, 4 minus 8 would be -4. -4 minus 5 ends up being -9. That's the y-coordinate of the vertex. So -2, -9 is the vertex of this parabola. And then part D is the graph of that quadratic function. Okay. And again, you're going to have coordinate grids on your final exam. All right, so now let's plot what we already have. The y-intercept we already have is 0, -5. So I stay at 0, but go down to -5. My two x-intercepts are negative 5, 0, so this will be to the left 5 on the x-axis, and the other one will be 1, 0, so 1, 0 will be on the x-axis as well. And then negative 2, negative 9 is the vertex, so I'm going to go to the left 2 and down 9. And also the axis of symmetry, if this helps, you can draw that in. The axis of symmetry always goes through the vertex. It's the vertical dotted line going through the vertex and the x-axis. That axis of symmetry is going to be x equal negative 2. So I'm going to draw in the axis of symmetry. Now, to get an additional point, we have to deal with symmetry here. Here's my y-intercept. That y-intercept is 2 places to the right. So a point on the other side of that axis of symmetry must be 2 places to the left. So it would be right here with the same y-coordinate. So these are enough points that I need to draw the graph of this parabola. And forgive me if my parabola is a little bit off a bit over here on this side, but you get the idea. That is the graph of the parabola. F of x is equal to x squared plus 4x minus 5. Okay. All right, now problem number 17. Number 17 is just evaluating the determinant of negative 3, 11 to negative 4. Okay, so this is problem number 17. So by taking the determinant or evaluating the determinant of a 2 by 2 matrix, we always take the product of the diagonal going from the upper left to the lower right. Okay, and pretty much I'm going to write this out so you'll see what I'm doing here. So here I'm going to be taking the product of this diagonal from the upper left to the lower right, which is at negative 3 times negative 4. And then it's going to be minus the product of this diagonal from the lower left to the upper right, 2 times 11. Now, simplifying this, if I do negative 3 times negative 4, that's 12, minus 2 times 11 would be 22. 12 minus 22 ends up being negative 10. So the determinant of that 2 by 2 matrix would be negative 10. Okay. All right, problem number 18 on your study guide. So you pretty much had to know how to do problem number 17 in order to do problem number 18, because you're going to be using Cramer's rule to solve this system. 4x plus 3y is equal to 15, and 2x plus 5y is equal to 1. Okay. So here's our system. 4x plus 3y is equal to 15, and the other one is 2x minus 5y is equal to 1. Now, when you're using Cramer's rule, you need 3 determinants. One for d, one for d sub x, and the third one is going to be for d sub y. All right. And if this helps you, D will always have the X coefficients in the first column and the Y coefficients in the second column. So for the D, and they have to be in this order here, here are your X coefficients right here, 4 and 2. And then the Y coefficients in the correct order, 3, -5. And then for the D sub X, instead of the X coefficients, you'll have your constant terms in the first column and then your Y coefficients. I'll go ahead and recopy those Y coefficients of 3, -5. The constant terms are right here, 15 and 1. Those go in the first column. And now for the D sub Y, the first column will be your X coefficients. Instead of the Y coefficients, you'll have your constant terms. So my X coefficients were the 4 and the 2, that goes here. The constants are 15 and 1, they'll go here. Each one of those, I'm going to find the determinants. And then that will help me find out the values of X and Y. So the determinant of D, which is my denominator, I'm going to do 4 times -5, that's -20, minus 2 times 3, which is 6. And if I do -20 minus 6, that's going to give me -26. And then for the D sub X, I'll write this down. 15 times -5, that's -75, minus 1 times 3, which is 3. -75 minus 3 will be -78. And then for the D sub Y, if I do 4 times 1, that's going to be 4, minus 2 times 5, which is 30. 4 minus 30 would be -26. So D sub Y would be -26. Now to find out what X is, I do D sub X divided by D. Here D sub X is -78 divided by the D, which is -26. Divide -26 into -78, you'll get +3 for X. And then for the Y, that's D sub Y divided by D. D sub Y is -26. Your D, the determinant in the denominator, is -26. -26 divided by -26 will be +1. So +1 would be your Y coordinate here. So my ordered pair solution for this system of equations in 2 variables would be 3, 1. Okay. All right. Now this is just going to conclude part 1 of this video, of this review for the final exam. I will have part 2 available for you on the next video, so be on the lookout for that.